Here's problem 9, 24. A 3 kilogram mass moving in the positive x direction with a speed of 10 meters per second collides with a 6 kilogram mass initially at rest. After the collision, the speed of the 3 kilogram mass is 8 meters per second, and its velocity vector makes an angle of 35 degrees with the positive x-axis. What is the magnitude of the velocity of the 6 kilogram mass after the collision? So, we have mass 1, which is 3 kilograms, moving initially in the positive x direction with a speed of 10 meters per second. It's about to collide with mass 2, which is 6 kilograms. Initial velocity in the x direction of 0. It's at rest. Then we're going to have a collision at a 35 degree angle. Mass 1 is going to proceed with a final velocity of 8 meters per second. That's its magnitude of its velocity final. And we'll have mass 2 proceed somewhat like this with some final velocity as well, which we don't know. We want to find that magnitude. And it's moving at some angle, theta, which we don't know either. So this is the way things look like initially over here on the left, and this is the way things look like finally over here on the right. Okay. Well, we're going to have conservation of momentum in any direction that we choose. So if we choose x and y, those are two directions where momentum should be conserved. And if we look in the x direction, we should have mass 1, v1 initial in the x direction, plus mass 2, v2 initial in the x direction, should equal mass 1, v1 final in the x direction, plus mass 2, v2 final in the x direction. Everything in the x direction specifically. Now v2 initial in the x direction is 0, so this whole term right here is 0. We know that mass 1 is 3 kilograms, moving initially in the x direction at 10 meters per second. The second term is 0. And we have 3 kilograms. Now v1 final in the x direction is just the x component of the final velocity. So final velocity is going 8 meters per second at a 35 degree angle. So v1 final in the x direction is going to be 8 times the cosine of 35 degrees. So for our final here is going to be 8 cosine 35 degrees for v1 final in the x direction, plus mass 2, which is 6, v2 final in the x direction. We have a bunch of numbers and v2 final in the x direction we can solve. v2 final in the x direction is going to equal 30 minus 24 cosine 35 degrees divided by 6. So what is that? 1.72 meters per second. So that is the component of v2 final in the x direction. We also need to find the component in the y direction. So if we look in the y direction, momentum will be conserved there as well. So we have mass 1, v1 initial in the y direction, plus mass 2, v2 initial in the y direction, should equal mass 1, v1 final in the y direction, plus mass 2, v2 final in the y direction. Now initially, neither mass has any velocity in the y direction. So v1 initial in the y direction is 0, and v2 initial in the y direction is 0. So there's no initial momentum in the y direction. So we're left with mass 2, v2 final in the y direction is going to equal a negative mass 1, v1 final in the y direction. That'll be a negative mass 1. Now v1 final in the y direction is 8 times the sine of 35 degrees. So we have that v2 final in the y direction is going to equal a negative mass 1, which is 3, times 8 sine 35 degrees divided by mass 2, which is 6. So what is that? 2.29, a negative 2.29 meters per second. So we have the two components of our final velocity for mass 2. If we were to graph that, we would have, looking back on this again, 1.72. We have 1.72 meters per second in the x direction and a negative 2.29 meters per second in the y direction for mass 2. So our net velocity is the vector sum of these two. To find the magnitude of that final velocity, v2 final, we would have to use the Pythagorean theorem. So v2 final is going to equal v2 final in the x direction squared plus v2 final in the y direction squared, those components, all that square root. So that's going to equal 1.72 squared plus negative 2.29 squared, all that square root. So that gives us 2.87 meters per second. So that is the magnitude of the final velocity for mass 2, 2.87 meters per second. Out of curiosity's sake, let's find this angle that it makes as it's veering off from the x direction. That angle theta, at least the magnitude of that angle, should be the inverse tangent of our y component, 2.29, over our x component, 1.72. So if we take the inverse tangent, 2.29 divided by 1.72, that is 53.1 degrees. So that's going to be 53.1 degrees below the positive x-axis. So mass 2 is veering off at 53.1 degrees below the positive x-axis at a speed of 2.87 meters per second. That's our final answer.